Okay, class, I need some help. Please focus on question 12. We've got a circle that passes through those points, and it has a radius of square root 10. Okay, so just imagine we've got a Cartesian plane again. They gave us two specific coordinates, 3, 5. So one point over here. This is point P, and point Q, -1, 3. So -1, 3 around here. It has a radius of square root 10. Okay, so your numbers you must be quite good. And square root 10 is approximately how much? 3 point a bit, right? Okay, so we can expect it to be, if it is square root 10, then the diameter will be about 6. Am I right? Yes. 6 point something. Okay, so possibly something like that. Right? It's just a sketch. I don't know whether it really looks like this or not. I think this is one possibility. Could I possibly have another circle? Maybe something like this? Possible also, right? You think it's possible? I think so lah. Okay, never mind. With all this, let's see what we can do. How should we start with part 1? Finding the equation of the circle. Okay, yeah, fine. Let's write down the equation. What does the equation of a circle look like? X squared plus y squared plus 2 gx plus 2fx plus c equals to 0. Is it right? Oh, so 2fy, yeah. Cannot have so many x, right? Okay. So if you want to use this, it will be able to tell us that the center equals to, what is the center of this circle if you are using this form? -g, -f. Then the radius equals to square root of g square plus f square minus c. Okay, you all seriously want to memorize this? I don't know. It's every time I ask you all circle question, you always come up with this one first. I don't know why. But no problem. We can go ahead with this. Now, we need to form equations already. Okay, take note that x and y, they are our variables. So, in our equation, how many unknowns do we have? X and y are variables. So, how many unknowns are there? 3 unknowns, okay. If there are 3 unknowns, I need 3 equations to solve. Am I right? Can I form 3 equations? Okay, name me a first equation that you can form. Sub p into the equation, is it? Okay, then let's see what happens. We will get 3 square plus 5 square plus 2g times 3 plus 2f times 5 plus c equals to 0. Okay, so you see there is one equation with 3 unknowns, right? That is my first equation. What is my second equation? Sub -1, 3. Okay, so -1 square plus, I can do this mentally. Okay, 9 plus 2 times -1 is -1, so minus g. Then 2 times 3 is 6, so plus 6f plus c equals to 0. Okay, this. Huh? Which one? This one or this one? -1 times 2g. Oh, yeah. Okay? Is this okay now? Okay, so this is equation number 2. There's one more piece of information we haven't used yet. What is it? Radius. Okay, how do we form an equation with the radius? Square root 10 equals to square root g square plus f square minus c. This is my equation number 3. So 3 equations, 3 unknown, you can solve lah. Can? So actually, from equation number 1 and equation number 2, you see that all the c will cancel off from equation 1 and 2. I've got 9 plus 25 plus 6g plus 10f plus c equals to 1 plus 9 minus 2g plus 6f plus c. So this part, the c and the c will cancel off. Then we can continue to simplify, and just with 3 equations, 3 unknowns, you definitely can solve one. Okay? What do you mean the other one? Completing a square. Okay, then if you want to do completing a square, right, you need to let the center be a comma b. And then you'll be solving for a and b. Again, they will have 3 unknowns. Any other questions? This is just the start for question 12 part 1. When you try completing the square. Why would you have 2? I mean 2 should be enough for completing a square. Okay, so go and try it out. It seems a bit tedious, but there may be other methods. If you do find them, please let me know. Then we see whether it can be done or not. Okay? Yes. To do what? Okay. For in general, coordinate geometry. If the coordinates are given and if equation is given, so it could be for a straight line, okay, y equals to mx plus c, then they give you one set of coordinates. It could be a parabola, y equals to ax squared plus bx plus c, then they give you a set of coordinates. It could be a circle, then they give you a set of coordinates. First thing you need to do is always substitute the coordinates into the equation. Because the coordinates must satisfy the equation, then I'm sure the equation will be halfway. Surely there will be some unknowns in the equation. That is when you need to substitute in the coordinates to find out the unknowns. Okay? So if you have coordinates given, equation given, sub coordinate into equation. This is one of the first few things that you can do. Whether straight line, parabola, cubic graphs also can. Whatever it is. Even the next part, topic 6c. Graphs or power function. Your logarithms, whatever, just substitute. Okay? Then from there, you need to come up with your plan. Sketch the graph to visualize. Then subsequently, you really need to come up with your own plan already. Whether it is perpendicular, whether you need to use product of gradients of perpendicular line equal to -1, whether you need to use your midpoint, all your other type of substitution, simultaneous equation, all those you'll need to figure it out yourself. Okay? So generally, these are the tips that I have. Any other questions before I move on to 6.3? Okay, then let's carry on. Graphs of power functions. So yesterday I asked you to do something very simple. Just go and trace only, right? Now I want you to, you see your textbook, there's quite a lot of white space, empty space. Can you go and draw out the graph of y equals to ax power -2 in one of the empty space? First thing, how many areas of the Cartesian plane does the graph fall under? You see there are 4 quarters, right? It falls in top 2. Okay, so above the x-axis. Okay, so you cannot have anything below the x-axis. Okay, first one, it should look like this. Okay, what is so special about this that I need to take note of? This portion, it must go closer and closer to the y-axis, but can touch or not? Cannot touch. Then on this side, you must go closer and closer to the x-axis, but can touch or not? Cannot touch. Next thing, for these two green color circled parts, do they ever become parallel to the x and y axis in my diagram? So they are not straight lines, huh? At the end, does your friend have a straight line at the end? If it looks like a straight line, right, help them circle and write down should be a curve. Get it? So have your friend make the corrections. Next thing to take note of is there is another side, right, on the positive y, negative x portion. We see very similar, we see a very similar shape. Okay, so again, this part should go closer and closer to the x-axis but cannot touch. This part goes closer and closer to the, sorry, did I say x? The vertical one y-axis, horizontal x-axis. Go closer and closer but cannot touch. Okay, then check that your friends have a label. Y equals to ax power negative 2. Got label or not? No label, help them include it in. One last point to take note. These two curves, you see there are two curves? They are symmetrical about the during your homework, when I ask you symmetrical about, when the question asks you symmetrical about what? You're supposed to tell us symmetrical about the y-axis. In this case, it is the y-axis. If the mirror is on your x-axis, that is symmetrical about the x-axis. Okay? So let me just give you a few more examples. If this is x equals to 1, then I have a graph looking like this. I'm trying to draw it symmetrical. Okay, now this graph is symmetrical about the line x equals to 1, yes. Later, I haven't talked about that one yet. Okay, there is another case for your logarithms. Okay, these two graphs, they were symmetrical about the line y equals to x. This was one of your homework questions. Ask you for the line of symmetry, right? So you're supposed to tell me that they are symmetrical about the line y equals to x. That's where our mirror is. Alright? Okay. Now, back to this graph again, y equals to ax power negative 2. Why is it that the graph falls above the x-axis? Why? Why isn't there anything here? For anything to be below the x-axis, what must the value of y be? Y must be negative, right? Is it possible for y to be negative over here? Why not? Because anything square will be positive, right? So, are you making an assumption about the value of a? What is the assumption you are making? You are assuming a is positive, right? Because if a is positive, x squared confirm positive. Positive divided by positive will be positive. That's why the graph is above the x-axis. Okay, let's look back at your page 196. Look at the second line. The figures below show the shapes of the graph of y equals to ax power n, where a is greater than 0. So they tell you that a is greater than 0. A is positive. That's why we are resulting in this. Okay so far? Now, is there a way for me to draw a graph that looks like this? Okay, not very symmetrical. Okay, what do you think is the equation of this graph? Y equals to negative a over x squared, where a is still greater than 0 lah. Okay, so when you take negative, positive number, you get a negative number. So for example, it could be y equals to negative 2 over x squared. Get it? So in this case, the value of a is 2. Then you put a negative sign beside it, you get negative 2 over x squared. Okay? What is the relationship between the graph of y equals to ax power negative 2 and y equals to negative ax power negative 2? What is the relationship between these two graphs?
They are both symmetrical.
They are symmetrical about the x-axis, yes. Okay, so this is the one in red, the negative. Okay? So you see, when I put a negative sign in front of the A, it reflects about the x-axis. Does that always happen? Let's do a simple graph, something that we're all very certain about. X, y. This is the graph of y equals to 3, for example. Now I want to draw a graph of y equals to negative 3. So I'm putting a negative sign in front, right? What does the graph look like? Below. Sorry, over here, y equals to negative 3. What is the relationship between the graph of y equals to 3 and y equals to negative 3? Symmetrical about the x-axis. So we see that as long as I put a negative sign there, it looks like it will flip. Then what other graphs do we know? Okay, parabola. So let's say we have this one, y equals to x squared. This y, this x. If I want the graph of y equals to negative x squared, smiley face or sad face? Sad face, parabola opening downwards. What is the relationship between these two graphs? Symmetrical about the x-axis. Okay? So now we are ready. Let us investigate a bit more. Why is it that the graph of y equals to ax power negative 2 must look like this? Why? Let's think about what happens when x gets bigger and bigger. Okay? A is just a constant. A is a positive number. When x equals to 1, okay? When x equals to 1, we have y equals to a divided by 1, which is a. So meaning if this is 1, then this must be a, isn't it? What happens when x equals to 2? Y equals to a divided by, are you sure it's 2? Divided by 4. Okay, so if this is a, this is half a, this is 1/4 a. Okay, I'm not drawing to scale, but you get the idea. What happens when a equals to 10? Okay, let's try something else. What happens when it's equal to 2, 3, 4, 5? What happens when x equals to 5? We get a divided by 25. That is much smaller already, isn't it? That's why I have a graph that looks like this. When you increase x, when x approaches infinity, when x approaches infinity, y approaches, what is it? Y 0. Why is it that when x approaches infinity, y will approach 0? Yeah, because you divide by a bigger and bigger number, right? When you divide by, when x equals to 5, you're actually dividing by 25. When x equals to 10, you're actually dividing by 100. So when you divide by 1 million, then the value will get smaller and smaller. You go closer and closer to 0. Okay, so, but it will never be 0. Because you still have something divided by a number. Then let's talk about this portion. What happens when x gets smaller and smaller? Okay, so since I've got x equals to 1, y equals to a, what happens when x equals to half? So y will be equals to a over 0.25. Okay, so that is actually 4a. Okay, so 4a is much higher lah. When it is half, it is actually much higher. This is supposed to be supposedly 4a. Okay, then when you go x tends to 0, when x approaches 0, y will approach infinity. You try dividing by a tiny number. You just take 10 divided by, for example, 100. Then you go more and more. 10 divided, no, not 100. 10 divided by 0.1. 10 divided by 0.01. 10 divided by 0.000001. The number gets bigger and bigger. Try the same thing, you will see that it works the same on the other side. Okay? Now, do you need to memorize this shape?
Yes. You should memorize all 6 graphs.
Okay, yes, you need to memorize, but are you able to roughly derive the shape if I tell you this method? You just try to imagine that you can use some numbers. Then you know how the graph will look like as x goes to infinity, as x goes to 0, as x goes to negative infinity. So the next graph we need to talk about is y equals to ax power negative 1. Okay, so you can switch your books back with your friend. Y equals to ax power negative 1 is actually the same as y equals to a over x. This is a case of inverse proportion. Remember from Sec 2? Inverse proportion. As k over x. In this case, I've got a over x where a is positive. As x increases, y will decrease. As x decreases, y will increase. Same thing, right? Same relationship over here. Okay, so the shape is very similar to what we had earlier on. This part will always go closer and closer to the x-axis. This part will go closer and closer to the y-axis. Because this region is positive x. So for our graph y equals to a over positive x, a is positive because that's the assumption given in your graph, in your textbook. Positive divided by positive, you'll get positive. So the graph is found above the x-axis. This is positive. Okay? But what happens when we have a case of y equals to a over negative x? When x is negative, y is negative, right? X negative, y is negative. Because positive a divided by negative x must result in negative y. And where is negative y found? Negative y is over here, right? Then we are talking about the case of negative x, which is over here. So where do they overlap? Left bottom. Okay? So the graph is found somewhere here. And we see that it's going to have the same relationship. Let's talk about when x is negative and when x tends to 0. Okay? When you take a divided by a number that is close to 0, what happens to the value? So use your calculator, try. When x equals to, for example, negative 0.0001, then y equals to a is just a positive number. You can just let it be equal to 1. 1 over negative 0.0001. What does your calculator tell you? Negative 10,000. Negative 10,000. Very, it's a large magnitude negative number, right? So where is it found on my y-axis? At the bottom. So can you imagine if your x goes closer and closer to 0, then it must go, the y value must go closer and closer to the negative infinity. So it is going to be somewhere over here. Then what happens when x is a very large negative number? For example, 10,000.
Still same.
Are you sure it's still same? So here divided by negative 10,000. So the answer will be get closer and closer to 0, right? Get closer and closer to 0. But is it a positive or negative number? Still a negative number. So somewhere here lah. So our graph will look like this. I am again trying to draw it symmetrical. Still not good enough. Okay, better? Yeah, okay, better. So now this is our graph of y equals to a over x. It has again two portions. Now I'm going to introduce, I've been talking about which part of the Cartesian plane. So you hear in names like top right corner, bottom left corner, this one, that one. Now I give you the correct name. This is known as the first quadrant. This is known as the second quadrant. What do you think this is called? Third quadrant. Oh, okay, but never mind, you can just follow. Fourth quadrant. It is just taken to be that way. It's just defined to be that way. Okay, so now we have name for it already. So where is this graph located at? First and third quadrant. Then what other characteristics can you tell from the red and the black color curve? Symmetrical about the line y equals to? Is it y equals to x? Y equals to x looks like this, no? This is the line y equals to negative x. So they are symmetrical about this line, y equals to negative x. Can? So is it possible now for me to have a graph that is like the green color one? Like this and like this. I want the green color graph now. How? How will you amend the formula, the equation, to give me the green graph? When a is negative. Yeah, you're right. So the green color one is known as y equals to negative a over x, where in this case a is still positive but you put a negative to it, then it becomes negative numerator. Get it? Okay, so we have talked about y equals to ax power negative 2, y equals to ax power negative 1, ax power 0. So kind of like a trick question. Y and x. What does the graph of y equals to ax power 0 look like? Indices, what does this tell us? Y equals to a. Because x power 0 is 1, right? So this is the graph. And since they say a equals 0, so this graph y equals to ax power 0. Then the trivial case. What if I've got a negative a? It's just here. Negative a. Y equals to negative ax power 0. Just simple. Then we've got a case of power 1. Y equals to ax power 1. What graph is this?
Straight line.
Straight line with a positive or negative gradient. Positive gradient. Slope up, slope down. What is the y-intercept? 0, yeah. So it looks like this. Y equals to ax. Then the other case where we have y equals to negative ax, what do you think it will look like?
Sloping down.
Okay, you can tell me sloping down based on your Sec 1 knowledge, right? Now if I tell you to think like a Sec 3 A-Math student, what is the relationship between y equals to ax and y equals to negative ax? Symmetrical about the y-axis, x-axis, right? We've always been saying they are symmetrical about the x-axis. Symmetrical about x-axis, like this, right? So in this case, because I introduced a negative sign, it is supposed to be symmetrical about the x-axis. Now I'm going to put a mirror on my x-axis. This is my mirror. The region over here, I reflect downwards, isn't it? So reflect down, it looks like this. Then this part, I reflect up, right? So look like this. Okay, wait. So this is my graph of y equals to negative ax. Am I right? Now, are there any other mirrors that you can place such that you get the same graph?
Y-axis.
Put it at the y-axis. Yeah, you are absolutely right. See, if I let this be my mirror, then I reflect it this way. This one reflected here, right? This one reflected here. I also get the same graph. So this is a case where we say that it is reflected. You can say it is reflected about x-axis. You can reflect about the y-axis. Same answer. But it is not always possible. For example, your parabola. If you reflect this one about the x-axis, do you get a different graph? If you reflect about x-axis, do you get a different graph? Yes, downwards, right? If you reflect about the y-axis, what do you get? If you reflect about the y-axis, what do we get? Same graph. Okay, so you must know the difference. Which this is our graph of y equals to ax power 2. Then this will be y equals to ax power negative 2. So far, I've covered 5 graphs. Out of these 5, you already know 3 very well, right? power 0, power 1, power 2. So what is new is just power negative 2, power negative 1. I'm going to tell you the last graph. Power 3. Now, watch carefully how I draw it, because this is the one that many students will make mistakes. Y equals to ax power 3. Okay? Watch really carefully. I will start from the origin. I will draw a line that is, I'll draw a curve up this way. Okay, it shouldn't go below the x-axis. Let me redraw it. It must touch the origin, because when x goes 0, y goes 0 ma, so it must be starting from the origin. Okay, like this. Notice this part. Compare this with the green color curve. What is the difference between the green one and the black one? Both are touching, both are touching origin. Huh? Gradient. Okay, talk to me about the gradient at the origin. Okay, gradient for the green graph is steeper, right? So if I put a ruler to find the gradient for the green graph at the point x equals to 0. So is this my gradient? Something like that, right? What is this gradient? Positive or negative? Positive. Now if I want the gradient for the graph in black, what do you think is the gradient? Based on my drawing, what do you think is the gradient of the graph in black? Or why don't you visualize the tangent line first? If I want the gradient at the origin for the black graph, what does the gradient line look like? You're going to put a ruler, right? You're going to take a ruler. Is it going to be slanted? Is it going to be horizontal? What is it going to be? For the black color curve. Draw a tangent at x equals 0. You should give me a horizontal line. Okay? You see for this at the origin, let me zoom in. For this curve in black, if I place a ruler to find the gradient at the origin, my ruler should look like this. A horizontal line. Okay? Now you look at your textbook. For y equals to ax cubed, at the origin, if you are asked to draw a tangent line at the origin, what will your ruler look like?
Just cut the origin.
You can cut the origin in many ways. You can cut horizontally like this, you can cut vertically, you can cut diagonally. According to the graph drawn in your textbook, you take a ruler, everybody take out a ruler now. Imagine you are supposed to draw a tangent line at x equals to 0. What does your ruler look like? It should be horizontal. Okay? And that is what I am looking out for whenever you draw or sketch the graph of y equals to x cubed.
Must draw the tangent line.
You don't need to draw the tangent line, but the graph, you have to be able to tell whether your graph is right or wrong just by looking at it. And I'm going to show you now how, by showing you different examples. So the one in black is correct. The one in green is not correct. Okay, so let me complete the graph. Over here, gradient equals 0 again. So it slopes down this way. The wrong method, the wrong graph will look like this. Can you tell the difference between the green one and the black one?
Is it because of a bit of straight line?
Not a bit of straight line. So pretend this is my ruler, okay? Pretend this, or rather, did I tell you about using scissors to tell the tangent line?
No.
Okay, were you taught of how to draw tangent lines?
No.
Nobody teach you how to draw tangent line?
No. You don't go and touch like that, really.
That's all you're told, right? Just touch, right?
Yeah.
Okay, now I'm going to help you visualize. Pretend this is my gigantic pair of scissors. Okay, so these are the blades. The blades of the scissors are sharp, right? When I ask you to draw tangent line, it is equivalent to asking you to cut out the curve. So primary school kid can do, right? Can take scissors and cut, right? Now when you cut along the black line, will you start cutting this way? Will you start cutting this way? Or will you cut this way? Option 1 or option 2? Option 2 lah. Then as you go along, your scissors will cut this way, or will you follow the curve? You follow the curve, right? So everywhere you go, you just touch the curve at one point, isn't it? Right? As you move along, you will just touch the curve at one point. And if I am interested in the tangent line at this point, for example, what does your scissors look like when you reach there? It should look like this, isn't it? Right? Your scissors cannot possibly look like this. Then that's not a tangent line anymore. So you imagine yourself cutting with a pair of scissors. Anywhere you want me to stop, that will be the tangent line. So if I say stop over here, this will be the tangent line. Get it? So by the time I go to the origin, what does it look like? Horizontal. Stop saying straight, because this is also straight, this is also straight. When you mean horizontal, say horizontal. When you mean vertical, say vertical. So over here, we have a horizontal tangent line. Yes? Okay. Then the gradient starts, the tangent line starts to go this way. So you see, tell me whether the gradient is increasing or decreasing as I move. Are you sure increasing? It is decreasing until it reaches? What is this gradient? 0. It's horizontal, so it is 0. Now what happens to the gradient now? Increasing. So it decreases to 0, then it starts to increase again. Yes? Now what about the green graph? If I want to find the tangent line, it looks like this. Right? Wow, very steep. Then it starts to get gentler and gentler. When I reach the origin, does my scissors look like this? No, it looks like something like this, isn't it? What is this gradient? Positive or negative? Positive. Does my gradient ever go to 0? No. So the green one is wrong. Okay? Are you now able to look and see straight away whether the cubic graph is right or wrong? Should be lah. Okay, so take 30 seconds. Go and sketch a cubic graph right now. Sketch a cubic graph. X power half is actually the same as? Okay, this is a square root x. Okay, so far, how to draw this graph? I never teach you before, but I want to see whether you can. Any other way besides substitution? Yes? Half is between 2 and 1. Nope. No, it's very hard to draw a graph like that. You all like square root? No. How about we square both sides? Let's see what happens when we square both sides. Y square equals to 9x. You know how to draw this graph? Yes. We just learned it yesterday, right? What is this shape? Parabola opening. Opening. Left or right? Opening to the right, because we are only going to have, you see on the left hand side, right, it's a y square, isn't it? So it must be positive, right? If the left side is positive, the right side must also be positive, isn't it? Therefore x must be positive, it is on the right side. So it is a parabola opening to the right. Now this graph over here is, it looks like this. So this is y square equals to 9x. Alright? But did they ask us to draw the graph of y square equal to 9x? No, they didn't. They said y equals to 3 square root x. So would there be a difference?
Half will be smaller.
What do you mean smaller?
Like
Compressed? No. What is the difference between these two? Okay, see, so this curve over here, y squared equal to 9x. Mathematically, right, largely the same, but there's one critical difference. Anything? Why? What about the y? What is the critical difference between these two boxed up equations? The y can be negative in the y square equation, is it? Do you all agree? The y can be negative over here. For the y square equation. But for this one, can your y be negative?
No.
Why cannot?
Because if you negative, then because cannot get square root. Then it's negative, you can't get square root.
Okay, so let's say for the first one, the original equation, if y is negative, let's say if it is negative, then the right hand side must be negative, right? Can this be negative? Cannot. This is a positive number, this is a positive number. See, the square root given to us is a positive square root. They did not give you a negative square root. They gave you a positive square root. So the positive times positive must give you positive. So can you have a negative y?
No.
Cannot. So the graph actually will look like this. This is y equals to 3x power half. Okay? Can? So you need to know the difference, the relationship between y squared equals to 9x versus y equals to 3x power half and the other graph. Now, I'm going to include the other graph over here. What is the equation for this graph at the bottom?
Negative y.
Y equals to?
3.
Wait, what? Negative 3x power half. Okay? This is the equation for the graph at the bottom. When we combine them together, when I combine these two graphs, I highlight them as a whole graph.
Y squared.
I get both this equation and this equation at the same time. Am I right? So y equals to 3x power half and y equals to negative 3x power half. Isn't it the same as y squared equals to 9x? Because from here, you can break it down into y equals to plus minus square root 9x, which is 3 root x, and, or you can say, or negative 3 root x. Okay? We break the square, y squared, into two parts, positive region, negative region. And it still holds the relationship. When I say there's a negative over here, you flip, the same thing still happens. Okay, so that's all I have. What about, you see we have done fractional powers already, but we only dealt with power half. Let's use software now to help us find out what about other powers. Okay, so textbook says let's find out what happens when n is equals to half, equals to 1/5, so on and so forth. So the first one, y equals to x. They assume that a is power 1. So here, sorry, they assume that a equals to 1. So now, y equals to x power half. This is a portion of the parabola, the positive portion. So what happens when y equals to x power 1 divided by 3? Oh, okay. Look at the one in blue. Look at the positive region now. Okay? It has quite a similar shape. Looks like a parabola, but it's not a parabola. The blue color one. The main difference is that, hey, it has negative values as well. It can have negative values of x. Does that make sense to you? When you have negative cube root. Yeah, you can cube root a negative number, but you cannot square root a negative number. Take out a calculator. Cube root negative 8. What will you get?
So if you can square root a negative number.
You can cube root a negative number. For example, you cube root negative 8 right now. What is your answer? Negative 2. You cube root, for example, negative 1000. What do you get? Negative 10. When you cube root a negative number, you get a negative answer. Right? That corresponds to the third quadrant. First quadrant on the top right, second, third. This is the third quadrant. Negative x give you negative y. When you try and square root a negative number, can or not? Cannot. So therefore, for the red graph, you don't have anything on the left side of the positive of the y-axis. So April just mentioned something. Even. You mentioned even, right? You can, okay, can you root, okay, let me rephrase. Very hard to say it out. Is negative. Let's put this as negative 10. Is this possible? Is a cube root positive or not? I mean, possible or not? Positive. How about this? 5. Fifth root. Okay, so we are seeing it. This one can or not? Can. Then 2, 0, 5, 8, 9, 7, 1. Can or not? Also can, because it's a odd number. So you can root a negative number as long as the root is an odd root. What about even? So when I don't write anything, it's taken to be square root, isn't it? This one can or not? This one can or not? Anybody needs to explain why cannot? Anybody? Okay. When you square root a number, when you square root negative 10, you are trying to find out something times something equals to negative 10, right? Something times something equals to negative root 10. Am I right? We're trying to find this value, this certain value over here. But is it possible for two of the same number multiplied together to give you a negative number? Not possible. Okay? So similarly, if I take fourth root, that means I'm trying to say that something times something times something times something equals to negative 10. All these are the same somethings. Is it possible? Not possible, because inside here, whether it is negative, 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 you'll still get positive. Whether it is positive, 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 you'll still get positive. You cannot get negative. Okay? So if it is even powers, you cannot have, you cannot root it. Okay, coming to the end already. Let's try powers that are greater than 1 but still fractions. So for example, y equals to x power 3/2. So 1.5.